So next up, we're going to see the binary search algorithm, right? So what is this binary search? So search for an element position in a sorted array. If the array is not sorted, then you need to sort it first. So that is the most important first thing. So in this approach, the element is always searched in the middle of a portion of array. So what actually happens in binary search is we get 2-3 conditions, right? We have to, what we do is we do not do that how linear search works basically. So we not go one by one and check each and every element of that array. So what we do is we find the middle element, and in which part that may exist, in that part we will only search. Either that element is going to be the middle element, or either it's going to be lying in the left side of the array or right side of the array. Suppose you want to search 20. So middle element is what? 12, let's say. So in the left part array, you can see 5 and 10. That is obviously will not be there, right? Because 20 is greater than 12. So one thing we are considering that this array is going to be what? It's going to be sorted. So we can definitely say that it's lying in the right part. And that way we're going to find the result at the last. So this is how we're going to do in the binary search. So we are dividing into half, and every time we try to find where it is there. So this is all about it. So we'll jump to the VS Code and we'll try to solve this question. So how we will do it. So we jump to the VS Code. Now we'll see the implementation of binary search. So what I'll do is I'll create here one file, that's binary search example .java. All right, I'll hit enter. The class is being created. Now we're going to see the step-by-step approach. We're going to see edge case handling. We're going to do each and everything one by one. All right, so what I have to do is I'll create the main method first. So simply we already do every time, that is public static void main method, and in this I'll pass string and we'll be writing argument over here. All right, now here I'm going to write the array. I'm going to take the array, int array, and let's define the array to be something value. So 1, 3, 5, 7, 9. Let's say these are the values I am taking. So these are in a sorted order that you have to consider, right? You have to take the sorted array. Let's suppose I want to find the number 7. So let's take integer and target value to be, let's say, 7. All right. Now what I'm going to do is I'm going to store that in one index. And what I'm going to do is I'm going to call that binary search function. So I'll write a binary search. I'll create a binary function here, and that I will be defining after that. So binary search here I'll be calling, and I'll be storing it in this variable index. I'll pass the array and I'll pass the target in it. Okay, all right. Now here I'm going to, after that, same thing we used to write in the linear search. If you remember, index is not equals to -1. That time, if it is not equals to -1, that time we'll say that system is system.out.println, and in this I'm going to say element is what we're going to give target, and that is found, right? So found at index, and we're going to give the index variable also. So I'll concatenate it and I'll write the index. All right, so this will give us the result. Let me click over here so you get it more bigger part. Now what I'll do is in the else part I'll be writing system.out.println, and in this I'm going to write element, and that's going to be what? Target plus not found. That element actually didn't found, that I'll write it in the array. Okay, this is the handling of the cases we did. Now what I have to do is I have to get out of this main method and I have to write it the binary search function that I've taken. So what I'll do is I'll create a private static. I'm going to return the index, so that's going to write int and binary search function is there. So here I'm going to write int, we're going to pass array over here and we're going to take the target. Now what I have to do is, you saw that we will say that first element to be will be considering, we can consider start also and left also. So I'll be considering as the left, and at the last element is going to be the right. So I'll declare one variable. That's how we're going to find the middle element, right? Because we're going to write left plus right, that divided by 2 is going to be the middle element that we know, right? So what we're going to do is I'll write int left is equals to 0, let's say, and int right will be, what is the last element? Last element is array dot length minus 1, right? That is the last element. Okay, now from here we'll perform binary search. Okay, so what to do to perform binary search actually? So we're going to do, every time we're going to divide that and we're going to write it in 3 major parts. Like we're going to check if it is if the middle element is the number we are searching, or it's in the left part, or it's in the right part, right? So what I'll do is I'll write in the while loop, because I don't know till how much it will run. So I'll write till left is less than equals to right, till that run this while loop. All right, and int mid will be found by formula, that is left plus right, and that is divided by 2. So this will be found by this. All right, now what we have to do in the step 2, that is check if the middle element is the target element. So what I'll do is, if middle element is the target element, so for that what I have to do is, if it means, so I'll write if statement and in array of mid, if that is equals to target, so I'll return directly mid from here. So it will directly return the mid, that element found actually. So element found. Okay, if this doesn't happen, so what will happen? That if the target is smaller, then search in the left half, right? If the target is smaller than middle element, if the target is smaller than middle element, element, then search in the left part. Okay, what I have to write? I'll write the if, and here array of mid, you can write else if also, that completely fine. All right, mid greater than target, then you have to find it in the left part. Okay, if let's suppose this is the mid, then this is mid minus 1, because start left is already there, so left to mid minus 1 will be the boundary, isn't it? So what I have to do, I have to update the right for the left sub array, right? So I'll do what? Mid minus 1. This is the logic behind that. Okay, if the target is larger than the middle element, then search in the right. So that will be covered in the else. Okay, if you are searching in the right part, so what actually you're doing is, your end is going to be, that is the right part is going to be remain same, but your starting position is going to change, right? If 7 is the middle, then this is always right, because this pointer we created, right? This is like the variable we created, right? So from 9 to 11 you have to check. So if this is mid, so 9 is mid plus 1, so we have to update the left of the right sub array, that is going to be the mid plus 1, and that's it. One most important part left is outside the while loop, that if element not found, so what you will write, if element you are searching for, if element searching for is not found, for that you will return -1 directly, and this will give the solution. I'll hit Ctrl S. Now I'll go over here and I'll click over the run, and let's run this program. So the code is running. 7 is found at the index 3. Okay, things to talk about here. So you already saw that we have divided where 3 condition is given. If middle element is that element, then element is directly found. If the element is smaller than the middle element, then you have to search it in the left part, and left is left sub array. You have to search. Left part is already defined, that is starting from 0. Then you have to update the right, because for that sub array right will be what? Right will be updated to mid -1. And in else part, if it is in the right side, then you have to update the starting part, that is the left part, from the end is going to remain same. That is what it is there. Okay, now thing is, what is the complexity of this code? So time complexity here, 2 time complexities may be there. So what is the one complexity is O of 1. So that is the best case time complexity. So the target element is found at the middle index in the first comparison. So that is going to be the best case. Average case and worst case is going to be O of log n. So why O of log n? In each comparisons, the search is halved, that is halved, right? Because we are dividing into mid, right? So resulting in a logarithmic time complexity. The algorithm divides the search range in half at each step, reducing the remaining elements to be searched by the half each time. As a result, the number of comparison required is proportional to the logarithmic of the number of elements in the array. The space complexity, if I talk, then binary search has space complexity to be O of 1. Since it does not require additional memory location, that scales with this size of the input. So the logarithmic time complexity of binary search make it significantly more efficient than linear search that we learned, because in linear search we had time complexity of O of n, that you have to iterate till n times. Binary search is suitable for sorted array, as it leverages the sorted nature of the array to quickly narrow down the search range. So by repeating, dividing the search range in half, it efficiently finds the target element if it is present there, that is to be considered. So this is all about binary search. Now we're going to solve tons of problems regarding binary search, and huge problems are created using binary search. So we're going to solve each problem and see how it is done. Thank you.